Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.5, integration by u-substitution for indefinite integrals. Let's take a look at a few examples. A. Integral phi x plus 1 to the power 10 dx. We can do this if we FOIL it out 10 times, but it is not efficient. So there's going to be a different way to do this problem. And a different way is well, look at the base there. It's phi x plus 1. So it will let u to be phi x plus 1. Then we can take the derivative of both sides with respect to x. D over dx of u, d over dx of phi x plus 1. And we have du over dx equal 5. du is phi dx. So I mean dx is 1 over 5 du. Oh, we have a substitution for the base and dx. Let us call it a u-substitution. Do the u-sub. And we have integral u to the power 10 times 1 over 5 du. Pull the 1 over 5 outside, integral u to the power 10 du. Well, the antiderivative of this is u to the 11 over 11 plus c. And we still have the 1/5 on the outside. It is not necessary to take 1/5 multiplied to c because a constant times a constant is just another constant. u11 over 55 plus c. And now we just do another sub, right? Sub for u. So we have phi x plus 1 to the power 11 over 55 plus c. And that is it. Pretty slick, huh? Well, if you take a look at the u-sub, right? Next time, you just have to remember that we are taking the derivative with respect to x on both sides. So you can just write du equal to phi times dx. It is a little bit faster. Here comes another example. B. Integration of tangent x dx. There is no antiderivative of tangent x. We can solve this using trigonometric identity. Tangent x is psi x over cosine x dx. Notice that the derivative of cosine is negative sine. So we can rewrite this as integral 1 over cosine x multiplied to sine x dx. Now we can let u to be cosine x and du is the derivative of cosine is negative sine x dx. Meaning that sine x dx is negative du. Do the u-sub. Integral 1 over u multiplied to negative du. So this would be negative ln absolute value of u plus c. And this becomes ln absolute value of u to the power negative 1 plus c. We can take the power negative 1 inside the absolute value. And that will give us ln absolute value 1 over u plus c. Now we do the sum. For u, we have ln absolute value 1 over cosine x plus c, 1 over cosine secant. So ln absolute value of secant x plus c. Pretty nice, huh? Okay, let's move on to do a few more examples. C, integral x square root 1 minus x dx. We can rewrite this as integral of x times 1 minus x to the power 1 over 2 dx. We have a base here, 1 minus x. So it would be a good idea to let it be u. U is 1 minus x. du is negative dx. So that means dx is minus du. We have a substitution for dx, 1 minus x. What about x? Look at the u substitution here. U is equal to 1 minus x. So that means x is 1 minus u. Now do the u sub. Integral 1 minus u to the power 1 over 2 multiply to negative du. Distribute the negative and we have u minus 1 multiplied by u to the power 1 over 2 du, which is the integral of u 3 over 2 minus u 1 over 2 du, and the antiderivative is u 5 over 2 over 5 over 2 minus u 3 over 2 over 3 over 2 plus c. Now do the substitution for u and we have 1 minus x to the power 5 over 2 times 2 over 5. So 2 over 5, 1 minus x, 5 over 2 minus 2 over 3 times 1 minus x to the power 3 over 2 plus c. Pretty nice. You can actually simplify this to make it look a little nicer. A little review on algebra. You can take out the 1 minus x to the power 3 over 2. And then in here, we have 1 over 5 times 1 minus x minus 1 over 3. Simplify this, we're going to have a 1 minus x 3 over 2. And we would have a 3 times 1 minus x minus 5 over 15 plus c. factor out the 1 over 15 and distribute the 3, then we don't want a negative 3x though. So factor out the negative 1 over 15, then we have negative 2 over 15, 1 minus x, 3 over 2, multiply 2, 3x plus 2, plus c. Yay! Let's do another example. D integral 1 plus x over 1 plus x squared dx. Now if you see something like this and you try to use up, it doesn't work. The strategy is to split this into two different integrals. First one is 1 over 1 plus x squared dx. The second one is x over 1 plus x squared dx. Oh, for the first one, this is exactly arctangent of x. For the second one, we're going to use the u sub. U here is 1 plus x squared. Du is 2x dx. So I mean x dx is 1 over 2 du. U sub integral x dx is 1 over 2 du. So 1 over 2 du. 1 over 1 plus x squared is 1 over u. Ah, pretty nice. Arctan x plus, well, this is half of ln absolute value of u plus c. So we have arctan x plus, do the sub for u, half of ln absolute value 1 plus x squared plus c. Notice that 1 plus x squared is already a positive because x squared is positive. Now, just get rid of this absolute value here. Use the potency. And then we can use the logarithmic rule, the power rule, to get arctan x plus ln 1 plus x squared to the power 1 over 2, or it's best to write this as ln root of 1 plus x squared plus c. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.